Now, this time let's talk about event streaming, event-driven architecture, and how to implement that with Camel. Although HTTP calls are dominating how users interact with the system, well, don't forget there's now many other creative ways to gather information, and these data can help to reshape how the organization make critical decisions and provide better services. Data will feed into the system continuously. With the increasing amount of data and the previous user requests, we need a better way to handle the load. When system reacts to the input, it causes a series of events, which means change of state. These events can trickle down and then triggers more actions. So if we use traditional request and response way to handle the events, it can be very time-consuming and very ineffective. For a cloud platform that has hundreds and thousands of microservices, it actually makes sense to implement event-driven architecture, where instead of waiting to be called, it's better to be reactive by subscribing to the event. The most important thing when dealing with events in an event-driven architecture on the cloud is you probably need a way to interact with most of the infrastructure middleware, such as, well, the superstar of today, Kafka. And then you probably want to have a way to filter and orchestrate events because you want to have the events going to the directions or the places you want it to head to. And then you also want to format, normalize the content of the actual business data so everybody understands what you're talking about. I'm going to show how to process the streaming data with Camel and how it connects with most of the common use streaming technology like Kafka and a broker using JMS. And also how Knative eventing works with Camel and to make the eventing-driven architecture serverless. Well, the background of this exercise is simple. We're going to create a hazard reporting system where it collects streaming data from SaaS services and gets input from local city police system. The exercise spans across 3 different namespaces. One is hosting the Kafka cluster on Kubernetes. We're using a project called StreamZ. And the other namespace is going to host a broker on Kubernetes. The main namespace has all the Camel applications. Let's get the infrastructure set up in the cluster. Before we go in, here's the list of requirements that you need before tackling this exercise. Make sure you have all this set up. If you don't know how, please check out my other videos. So in the namespace event streaming Kafka cluster, well, if you don't have one, please create one. Install the StreamZ operator. Here I'm using the AMQ streams. It's Red Hat's version of Kafka on Kubernetes. Find the operator in the operator hub and then subscribe it to the namespace. The setup of Kafka cluster and also install all the Kafka topics that's needed. Next up, we're setting up the broker that receives alert and notification. Go to the namespace Event Streaming Messaging Broker. Again, create one if you don't have one. Install the Artemis operator. Here I'm using the AMQ Broker. Again, it's Red Hat's versions of Messaging Broker on Kubernetes. Find the operator in the operator hub and then subscribe it into this namespace. Now let's head back to the workspace and then run the setup for the broker and the addresses that exposes this broker. Okay, now we're going to set up Camel in the application namespace. In the Camel event streaming namespace, again, create one if you don't have one, and install the Camel operator. Same old drills, find it in the operator hub, and then subscribe it to this namespace. And now we're going to take a look at the broker and Kafka address. Open up the application property file and make sure that it's mapping what you saw in the terminal. This is going to be used to configure our Camel application, and that's it, find the Kafka and broker services. And then we're going to install this property as a secret on the cluster, so the Camel application can locate it later. Okay, now we have set up everything that we need as far as infrastructure goes. So let's go ahead and create the first reporting flow, the air pollution hazard. It starts a Camel integration that consumes data from OpenAQ API. This API is a publicly available service that reports air pollutions around the globe. So the Camel splits each record and then convert the data into JSON formats, and then send them to a Kafka topics called PM data. If you look closer, we're using the Camel Kafka components. It provides developer a super simple way to communicate with Kafka. Same as the other Camel components, all the developer needs to do is to configure everything in the property file or in the URI. So Camel will write the data into the topics without needing to write any specific setup in your code. So run the Camel command and then start openaq consumer.java. Notice in the command it also imports other models that's needed to run. Now we're going to start up the pollution bridge. This microservices-like integration further process each individual events and then populates the data into two different places. That's event orchestration. First, it goes to a Kafka topics called timeline data. This timeline data topic stores all the incoming events in order. And then it sends to a alert notification topics in the broker, depending on the pollution level. In the code, notice that we're using SJMS2 component in Camel. SJMS2 stands for Simple JMS 2.0 component. This is a best practice to configure and communicate with the messaging broker because it's lightweight and resilient. Now we're going to go ahead and then run the Camel command that will start up pollution bridge. Next up, we're going to start up another microservices-like integration called Timeline Bridge. This one just reads off from timeline data that we published before and then exposes information through a RESTful API service call. Okay, now follow the command line that sets up a simple Node.js application that will gather all the hazard information from the timeline using the RESTful call that we created before. Once it's deployed, go to the developer console and then locate the route of this front-end application and then go to that URL in the browser. You should be able to see all the pollutions displayed in the console. Event comes in various forms and shapes and could be using different protocols to communicate. They don't necessarily talk in HTTP, and the flow of these events are often not one-to-one. In order for us to scale it out easier, we need to broadcast it and allowing services to subscribe to these events and sometimes orchestrate these events too. And when it's not in use, this service can be scaled down to 0 and then as Knative. So if you ask me, Knative eventing is the implementation of event-driven architecture for serverless. The events floating in Knative eventing are called cloud events. Basically, it standardizes what events are with a set of metadata, so we know where the event is from, where it's going, and what type it is, without the need to dive into the actual business data to avoid a lot of customization in the system. So it can be interoperable across platforms and systems. You will need a source that takes in events from third-party systems and then convert them into cloud events. After a source obtains the events, it will pass it to a sink. A sink can be a Knative service and start processing the events right away. But there's a problem, or a catch. Similar to how we handle HTTP load, when the service capacity overflows, we will start losing some of the events. So instead of having to wait for the process, we're going to create a channel in between. Sounds familiar? Yeah, it's how we do event-driven architecture. But this time, we're going to use channel instead. The channel itself can be implemented in many ways. The common ones I see today are 1. In-memory, 2. Kafka. After creating the channel, we can now subscribe to it and then start to process accordingly. There is another concept of broker and triggers in Knative eventing, but as a CamelK developer, I don't really have to worry about it because CamelK is powerful enough as it does most of the job that trigger does in the comfort of using simple Camel DSL. So long story short, for CamelK, you can create Camel source to obtain the events and convert them into cloud events without breaking a sweat, and easily subscribe to the channels to get those events, applying enterprise integration patterns to the events. Going back to our exercise, let's go ahead and set up infrastructure for serverless in our cluster. make sure that you have Knative Serving or Red Hat Serverless installed already. If you don't know how, please visit my previous videos. Well, in addition to pollutions, we wanted to also support crime as part of the hazard report. And thank God these data doesn't come in quite as often as air pollution ones. So it's a great place to introduce serverless, as we can scale it down to 0 when nothing is happening. Let's first install Knative Eventing into the cluster. Go to the Operator Hub and look for Knative Eventing. And since this is a cluster-wide operator, just subscribe it. Now let's set up the channel by simply executing the command. And this is what the definition looks like. Basically, we're starting up a in-memory channel. Now we'll spin up a source in Camel that takes in crime reports from the city police system, and then place the incoming events into a Knative channel as my sink. So here's a Knative endpoint that we define in Camel. This automatically gets generated into Knative service with its endpoint, and Knative will create the routes accordingly, and it's ready to receive cloud events. And here we're also applying an enterprise integration pattern called wiretap that simply makes a copy of the events and then reroute that elsewhere. When rerouting, we're simply putting the events into the sink that we just defined before, and then to do that, simply specify the name of the channel. Now the auditing application. It records all the incoming events and also the ones coming in the future. In order to get ready for the possible burst of data, we choose to have channel as its sink for all the incoming events. The other service will pick it up from the channel and just do a log. Here, see, we only need to specify which channel to subscribe to. And we also want to spin out the bridge so the crime info will also get populated into the display. Now watch all the pods scale down to 0 when not in use. Now I'm gonna go ahead and send a crime report. When the request goes in, see how it wakes up both Camel apps? And now our Camel application can handle events or requests in a serverless way. In summary, I have shown you how Camel can stream data or get streaming data from AMQ Stream, Red Hat's version of Kafka on Kubernetes, and how to send message to a broker using JMS protocol. And I also briefly covers Knative Eventing as it's an event-driven serverless architecture framework. And lastly, showing you how easy it is for Camel to stand up a Knative endpoint, subscribing to a channel, and show you Camel is a very powerful tool when orchestrating these serverless events. Thank you.